All right, so let's start today's class. Today we're going to focus on the common techniques to factor quadratic expressions. So the reason we practice these is it is the foundation to solve quadratic equations, which we'll be learning in the next chapter. So I hope you can get yourself familiar with all the techniques mentioned here. Okay. All right, let's see the examples and all the questions here. Okay, the first technique is to factor out the greatest common factor. This is probably the easiest technique, right? So first of all, if there is a greatest common factor, we can just put the greatest common factor in front. And as you can see here, this can be factored to s times s minus 7, right? All right, next one. So note that x plus 7 is the greatest common factor. So we can put it in front, and what's left behind is 3x minus 2, right? So basically, it's just the reverse process of using the distributive law. Okay, next, as you can see here, 2x plus 3 is the greatest common factor, right? So put 2x plus 3 times x plus 5, right? So remember, first of all, do check if there is a common factor. If there is, you can just put the common factor in front, okay? All right, the second technique, special expressions. There are some formulas we can use to factor quadratics. For example, the difference of squared. A squared minus b squared equals a plus b times a minus b, right? And a squared plus 2ab plus b squared is a plus b as a whole squared. And then a squared minus 2ab plus b squared is the difference of a and b to the power of 2. Okay, so we can use these formulas to factor the quadratics. For example, as you can see here, this expression can be vectored. First of all, note that there is a common factor, right? 4 is the greatest common factor. So let's put 4 in front. And then we can use formulas to factor this. This is actually a squared minus b squared, right? Because 4 is just 2 to the power of 2. So 4 times x plus 2 times x minus 2. Or there is a typo here. There should be a factor of 4. Okay, let's see the practice. First one, this is actually 7 squared subtracted by p squared, right? So a squared minus b squared is 7 plus p times 7 minus p. Okay, next one. This might be a squared plus 2ab plus b squared, right? So as you can see here, 10x is just 2 times x times 5, right? And this number happens to be 5 squared. So this can be written as x plus 5 squared, right? Remember that you can always verify your result by expanding the factored form back, which is x squared plus 10x plus 25, which should be exactly the same with the original expression. right? Okay, next one. So note that 9x squared is 3x squared, and 48x can be written as twice of 3x and multiplied by 8, right? And 64 happens to be 8 squared. So this can be rewritten as, this can be factored to 3x plus 8 squared, right? And if we verify the result by extending this, you can see this is actually 9x squared plus 48x plus 64, which is exactly the same with the original expression. That means our factoring is correct, right? All right, next one. So note that 4y squared is 2y to the power of 2, right? And 36 can be written as 2 times 2y times 9, right? And here the 81 is 9 squared. So again, we can use the formula a squared minus 2ab plus b squared. So this can be factored to 2y minus 9 squared. Okay, and if you verify your result, you can just extend it to 4y squared minus 2ab, which is 36y plus b squared, which is 9 squared, which is 81, right? And this expression is exactly the same with the original expression. So that means our solution is correct. All right, next one. We have x squared, and 1/4 is 1/2 squared, right? And note that x is 2 times x times 1/2, right? So again, we can use the formula a plus b to the power of 2 equals a squared plus 2ab plus b squared. So this one is just x plus 1/2 to the power of 2, right? And again, better to verify our result by expanding the factored form, which is x squared times plus 2x times 1/2 plus 1/4, which is x squared plus x plus 1/4, which is exactly the same with the original expression, right? So that means result here is correct. Okay, any questions? No? Okay, let's see the next technique, which is called trial and error, also known as cross multiplication. Okay, first let's have a look at the example. So suppose we have a quadratic like this, x squared plus 5x plus 6, right? Usually this can be factored to x plus a times x plus b, right? So you need to ensure that the first term with the highest order here, this is factored to, this can be factored to x times x, right? And 6 can be factored to 1 and 6 or 2 by 3, right? In order to have a 5x here, we need to do a trial and error. For example, if we factor 6 to 1 and 6, then by cross multiplication, we'll get 1 times 6 plus 6, 1x plus 6x, which is 7x. This is not 5x, right? So in this way, it does not work. Let's try the other way. Okay, first term factored into x and x, because x times x is x squared, right? And this time we factor 6 into 2 by 3. And by cross multiplication, we can have 2x and then plus 3x, which is exactly 5x, which is the same with the term here, right? So this is a solution, right? And how to determine the factors? Factor is here and here, right? So the first factor would be x plus 2. X, as you can see here, x plus 2. Next vector is x plus 3. So x plus 2 times x plus 3. And again, you can always verify the result. If you verify the result, you can just expand this to x squared plus 3x plus 2x plus 6, right? Which is x squared plus 5x plus 6, which is exactly with the same one as the original expression, right? So that means our factoring here is correct. Do you understand? Okay, now let's have a look at the practices here. So first one, we have x squared, right? X squared can be factored to x and ax, because x times x is x squared. And then here we have 15. 15 can be factored to 1 times 15 or 3 by 5, right? In order to have 8x here, apparently factoring 15 to 3 by 5 would be a possible answer. Now let's check. 3x is 3 by x is 3x, 5 by x is 5x, and 3x plus 5x is 8x, and 8x is exactly with this term in the middle, right? Okay, so this factoring is workable. So first factor would be x plus 3, right? X plus 3 is a factor. Next factor is x plus 5, right? First row is one of the factor. Second row is also one of the factors. So the original expression can be factored into x plus 3 times x plus 5, right? Again, let's verify the result by expanding this expression. First of all, x squared next plus 5x next plus 3x and next plus 15, right? And this is x squared plus 8x plus 15, which is the same with the original expression. That means solution here is correct. Okay, any questions? No? All right, let's see the next one. Next one, note here, first we have x squared, which can be factored to x times x, right? And here we have minus 24. Minus 24 can be factored to a multiplication of two numbers, right? And note that we need to have a minus 5 here. So let's try. Apparently, if we factor that, the 24 to 1, minus 1, 24, that's not working, right? Because we don't have minus 5x there. So how do we get minus 5x? Note that 24 can be factored to 3 by 8, right? And this time we have minus 24. So we have to put a minus sign in here or in front of 3 or in front of 8, right? So where should we put that depends on how do we get the minus 5x. If we put it here, you will get 8x minus 3x. This is 5x, not minus 5x, right? We can't put it there. The only way we can put it, the only way we can do is to put in front of the 8, right? So in this way, we will have 3x minus 8x, which is exactly minus 5x, right? Okay, so this is a possible factoring. So the first factor would be x plus 3, right? And next factor is x minus 8. So note here, there is a minus sign here. Okay, so the original expression can be factored to x plus 3 and x minus 8, right? And if we verify the result by expanding this expression, you can see this is actually x squared plus 3x minus 8x minus 24, which is x squared minus 5x minus 24, which is exactly the same with the original expression, right? So that means the result here is correct. Okay, any questions? No? All right, let's see the next one. Now, you should be familiar with the technique now, right? So first of all, r squared can be factored to r and r, because r by r is r squared, right? And 28 can be factored to 4 by 7, right? 4 by 7 is 28. But note that we will be having a minus 11 here. So how do we get the number here? We can just put two negative signs in front of two numbers here. For example, minus 4, minus 7. So by using this, we will have minus 7r minus 4r, which is minus 11r, which is exactly the same with the middle term here, right? Okay, so in this way, the first term would be r minus 4, right? And the second term is r minus 7, correct? Okay, so now let's now the original expression is factored to r minus 4 times r minus 7. And actually, we can verify the result, okay, by expanding the expression here. This is r squared, then minus 7r, and then minus 4r, and plus 28, which is r squared minus 11r plus 28, right? And as you can see here, this expression is the same with the original one. So that means our factoring here is correct. Okay, I strongly recommend you to verify your result after you have done the factoring. Okay, sometimes if you verify, the result is different with the original one. That means your result here is not correct. And in that case, you need to rethink how do you decompose one of the expression here. Okay, so that's why this technique is called trial and error. So you can try different combinations and to see which combination can get you the middle term here. All right, let's see the next one. Okay, so next one, note that this is x squared and this is 5 squared. So first of all, let's check if we have twice of the term here and here. So the middle, the term in the middle here happens to be twice of x and 5, right? Because 2 by x by 5 is 10x. So you can just directly use the formula. This is actually x plus 5 squared, right? Also, you can use the trial and error method. So if we use the trial and error method, you can see that x squared can be factored to x and x, and 25 can be factored to 5 by 5, right? So by cross multiplication, we will get 5x plus 5x, which is 10x, right? And this one is exactly the term in the middle. So by using this technique, the first term here is x plus 5, and second term here is also x plus 5. So the original expression can be factored to x plus 5 times x plus 5, which is also x plus 5 to the power of 2. You understand? Any questions? No? Okay, let's see the next one. All right, next one. First, we have 56, right? So for 56, we can factor it into 1 by 56 or 7 by 8, right? And the more intuitive way is to factor it by 7 by 8. And note that we need to have a -1 here. Okay, so let's try 7 by 8 for the first term. And for the last term, oh, sorry, let's rewrite this expression first. Usually we'll write it like this, or we put the term with the highest power in front. Okay, so let's put all the terms in the order from either from the highest power to the lowest power, or from the lowest power to the highest power. So let's use this one for factoring. Okay, so now we have a minus x squared, right? Minus x squared can be factored to minus x and x. And then we have 56, which can be factored to 7 by 8. So in this way, we will have 7x minus 8x, right? And this is minus x, which is the term in the middle. So this combination is workable. Now, from this, we can see that the first term is minus x plus 7, right? And the second term is x plus 8. All right, so the original expression can be factored to minus x plus 7 times x plus 8, right? And again, let's verify the result, which is by expanding the factored form, right? First of all, we have minus x squared, next minus 8x, and next plus 7x, and next have 56, which is minus x squared plus, sorry, minus x plus 56, which is the same as the original expression, right? So that means the result here is correct. Okay, please have a look at this. Any questions? No? All right, let's see the next one. Next one, 2x squared can be factored to x and 2x, right? Because x by 2x is 2x squared. And then we need to factor this number, minus 35. Okay, minus 35. We can try 5 by 7, right? So if we put a 5 here, 7 here, and we also need to decide the position of the negative sign. So if we put a negative sign here, we will get 10x subtracted by 7x, which is 3x. 3x is not the term here, right? The term here is minus 3x. So this way, in this way, is not working. So then let's try putting the negative sign here in front of the 5. And in this way, we can see we have minus 10x plus 7x after we do the cross multiplication, right? So this is minus 3x, which is a term in the middle. So this way is working. And then the first term would be x minus 5. And next term would be 2x plus 7. So the original expression is x minus 5 times 2x plus 7. And again, please verify your result in your scratch paper to make sure it is correct. Okay, if you expand this factored form, you will get first 2x squared, then plus 7x, then minus 10x, then minus 35, right? Which is 2x squared minus 3x minus 35, which is the same with the original expression. So this solution is correct. Okay, any questions? No questions? All right, let's have a look at the next one. Okay, first 2x squared, which can be factored to x and 2x, right? And minus 45, intuitively, my guess would be 5 by 9, right? So either minus 5 by 9 or 5 by minus 9, right? These are two possible combinations. Or you can also try 1 by 45, or minus 1 by 45, or 1 by minus 45. Okay, you can try any of these combinations. And note that we should have an x by conducting the multiplication, cross multiplication. So how do we get the x here? So for example, if we use minus 5 by 9, is it working? So let's check. 2x by minus 5 is minus 10x. And x by 9 is plus 9x, which you will get minus x, which is not the term in the middle, right? So in this way, it's not working. The trial is not correct. So let's try 5 minus 9 this time. 2x by 5 is 10x, and x by minus 9 is 9x, right? So 10x subtracted by 9x is x, which is exactly the term in the middle. So in this way, it's working. And if it's working, the first factor would be this one, right? Which is x plus 5. And the second row corresponds to the next factor, which is 2x by 9, right? Okay, so the original expression is factored to x plus 5 times 2x minus 9, right? Okay, again, it's better to verify our result by just expanding the factored form. So first of all, 2x squared next. X by minus 9 is minus 9x, and then plus 10x, and then minus 45, right? Which you will get 2x squared plus x minus 45. which is exactly the same with the original expression. So that means our factoring here is correct. Okay, please have a look at this. You have any questions? No? Okay, let's see the next one. So next one is more flexible, right? So because 12x can be factored to 3x by 4x or 2x by 6x, right? So you have many ways to factor 12x. So let's try 3 and 4 first. Then note here minus 15 can be factored to minus 3 by 5 or minus 5 by 3. You can try either way, right? So first of all, let's try minus 3 by 5. Apparently, this will not give you the minus 8 here, right? Because not minus 12 plus 15, this will not give you the minus 8 there, so it's not working. You can also try 3 by minus 5, and this time it's not giving you the minus 8x either, right? So let's try the other combination. How about this time? How about we have 2x and 6x here, right? And in order to have a minus 8, my guess would be, how about we put a 5 here and a 3 here? So as you can see here, 3 by 6 is 18x, right? In order to have a minus 8, we can just put a minus sign here. And if you put a minus sign here, you will get minus 18. And then by this cross multiplication, we will get plus 10x. So minus 18x plus 10x is minus 8x, which is the same with the term in the middle, right? So it all involves trial and error until you get the right combination, right? Okay, so if this combination works, the first term is your first row, right? First row is 2x minus 3. This is our first factor. Next factor would be the second row, which is 6x plus 5, right? Okay, so the original expression is factored to 2x minus 3 times 6x plus 5, right? And again, for some more complex cases, I strongly recommend you to verify your results because you can easily make mistakes here. So if we verify the result, first 2x by 6x will give us 12x squared, right? And next 2x by 5 will give us 10x. And then minus 3 times 6x gives us minus 18x. And last, minus 3 by 5, it gives us minus 15, right? So this is actually 12x squared minus 8x minus 15, which is exactly the same with the original expression. So that means our guess here is correct. The original expression is factored to 2x minus 3 times 6x plus 5. Okay, any questions? No? Okay, let's see the next one. Next one, there's a little trick there. So note 8, the coefficient 8 and coefficient 15 here. If we put this number, if we add these two numbers, you will get 26, which is a coefficient in the middle, right? So when you factor the first and the last coefficient, you want to keep the 8 and the 15 in order to get 23, right? Okay, so follow this logic. The first term can be factored to 1x and 8x, right? You want to keep the 8 here. 1x and 8x. If you multiply these two terms, you will get 8x squared. Okay, so that's working. And again, we want to keep the 15 here. And 15 can be factored to 1 by 15, right? So in this way, by cross multiplication, as you can see here, first you will get 15x. Next, you will get 8x, right? So 15x plus 8x is 23x, which is term in the middle here. So this is working now. And first row corresponds to the first factor, which is x plus 1, right? If it is 1 here, usually we will not write the 1 here. So it's just x plus 1. So next, the second row corresponds to the second factor, which is 8x plus 15, right? Okay, so the original expression is factored to x plus 1 times 8x plus 15. Okay, again, let's verify the results. Okay, first of all, if you expand the factored form, you will get 8x and then 15x and then 8x and then 15, right? Which is 8x squared plus 23x plus 15, which is the same with the original expression. So now we know that the factoring result is correct. Okay, please have a look at these examples. Do you have any questions to ask? No? All right, let's see the next technique. Okay, so sometimes it's not very easy to find a right combination, right? So the trial and error may not be working for some time. So in that way, in that case, we can consult the method called completing the square. So for example, if we have an expression like this, x squared plus 4x plus 1. First, you can see that x squared plus 4x might be part of the formula, right? So we can just try x plus 2 to the power of 2, right? X plus 2 to the power of 2 is x squared plus 4x plus 4, right? But there is no plus 4 in the original expression, so we need to subtract 4 in order to keep it the same with the first part, right? And note that there is a plus 1, so we need to add the plus 1 to the back as well, right? Okay, so the original expression is rewritten to this one, which is equivalent to x plus 2 to the power of 2 minus 3, right? Now, as you can see here, 3 is actually square root of 3 to the power of 2, right? So now we have something squared minus something squared. So we can use a formula here, which is x plus 2 plus square root of 3, and then x plus 2 minus square root of 3, right? Okay, so let's have a look at the practices here. Okay, so first part, as you can see here, might be this one, right? X minus 1 to the power of 2. So this is x squared minus 2x plus 1, right? There's no plus 1, so we need to subtract 1 to eliminate the extra term here. And then there is another minus 1 there. Okay, so a minus 1 again. Okay, so this is actually x plus 1, x minus 1 squared minus 2, right? Also, I strongly recommend you to verify if this is correct. If you verify this, this is x squared minus 2, x plus 1 minus 2, which is x squared minus 2x minus 1. This should be the same with the original expression, right? Okay, so that means our solution is correct to this step, right? So it's not over yet. This is not affected form. So note here, 2 is square 2 to the power of 2, right? So again, we can use the formula, which is x minus 1 plus square root 2 times x minus 1 minus square root 2, right? Okay, any questions? Oh, all right, let's see the next one. Okay, so x squared minus x. We can try using x minus 1/2 square first, right? So in this way, you will get x squared minus x plus 1/4, right? There is a extra 1/4, so we need to subtract 1/4 here. And then note here we have another term, which is 3/16. Okay, so the original expression is converted to this one, which is x minus 1/2 square minus this 1/4 is actually 4/16, right? So if we calculate these, this is minus 1/16, right? So this is x minus 1/2 square minus 1/4 square, right? And now again, we can use a formula. We have a difference between two square. This is x minus 1/2 plus 1/4 times x plus 1/2 minus 1/4. Remember, this is not finished yet, right? We can combine these two terms. So please simplify your result to x minus 1/4 times x minus 3/4. All right? Any questions? No? Okay, next, let's have a look at question C here. So note here, 9x squared is 3x to the power of 2, right? So we can try 3x minus, so here we can decompose this to 2 by 3x by 2, right? Okay, so we can try using 3x minus 2 squared first. And this is actually 9x squared minus 12x plus 4, right? There is no plus 4 in the original expression. So we need to subtract is 4 to the 3x minus 2 to the power of 2. And then this is actually the first two terms, right? And there is another term plus 15 over 4. So we can just add this term at the back. So this is 3x minus 2 to the power of 2 minus 4 is the denominator, and the numerator would be minus 1, right? Okay, so here we have 3x minus 2 to the power of 2 minus 1 over 2 squared. Again, we can use a formula to factor this. This is actually 3x minus 2 plus 1 over 2 times 3x minus 2 minus 1 over 2, right? Okay, again, remember to simplify your result. First factor can be simplified to 3x minus 2 over 3. Next factor can be simplified to 3x minus 5 over 2, right? This should be your final result. Okay, all right. Please have a look at these solutions. Any questions? All right, if you have no questions, let's have a look at the other technique, which is called substitution, which is usually for quadratics in disguise. So by quadratics in disguise, I mean, actually by using substitution, you can convert the original expression to a quasi-quadratics, right? So let's have a look at the example here. Example is not a quadratic, right? Because we have x to the power of 4. For quadratics, usually the highest order would be a 3, right? But note here we can use a letter u to substitute the x squared, right? So if we let x squared be u, then the original expression can be rewritten as 15u squared plus 38u plus 7. This is a quadratic for u, right? So we can try to factor these expression first, which can be written as 3u plus 7 times 5u plus 1 by using the trial and error method, right? And then put u is x squared, put the x squared back, which you will get 3x squared plus 7 times 5x squared plus 1, right? Okay, so now let's see some examples. First of all, this is not a quadratic, right? But if you use u to substitute x squared, this one becomes 4 times u squared minus 9. This is actually 2u to the power of 2 minus 3 to the power of 2, right? So by using this formula, we'll have 2u plus 3 times 2u minus 3, right? And remember, u is actually x squared. So let's put x squared back into the expression here. You will get 2x squared plus 3 times 2x squared minus 3, right? This one cannot be factored either further, but this one can, right? So this one is actually square root of 2 times x to the power of 2 minus square root of 3 to the power of 2, right? So we can use a formula to factor the later part, which is square root of 2x plus square root of 3 times square root of 2x minus square root of 3, right? Okay, do you understand? All right, let's let's have a look at the next question. Next question, this is not a quadratic, right? Because for quadratic, the highest order would be 2. But this is actually quadratic in disguise. Why? Because we can use a letter u to substitute x squared, right? If we use a u to substitute x squared, the original expression can be rewritten as 6u squared minus u minus 2, right? And then this can be factored by using the trial and error method. So 6 can be factored to 6u squared can be factored to 2u by 3u, right? And minus 2 can be factored to 1 by minus 2 or 2 by minus 1, right? In order to have a minus u here, I think you should put a minus 2 here and 1 here. And in this way, you will get minus 4u plus 3u, which is minus u, which is a term in the middle, right? So the first term would be 2u plus 1. And next term would be 3u minus 2. And then you can put the x squared back to substitute the u, right? 2u is actually 2x squared, and then plus 1. And 3u is actually 3x squared minus 2, right? And remember that this is not over yet. We can use a formula to factor this again, right? So this can be rewritten as square root of 3x minus square root of 2, and then square root of 3x plus square root of 2, right? Okay, so please have a look at this question. Anything you want to ask? Oh, okay, so next, I just want to mention that not every quadratic can be factored. If a quadratic cannot be factored in real number set, it is a prime quadratic. Okay, it is called a prime quadratic if it cannot be factored in real number set. Okay, for example, in the real number set, it is not possible to factor this quadratic. So this quadratic is called a prime quadratic, right? That means it only has a factor of 1 and itself. Understand? All right. So next key point is to rationalize the denominator. So how do we rationalize a denominator? There are several cases, right? So first case, we can just rationalize the denominator by times the same number to the denominator, right? So for example, if you want to rationalize this number, you can just times the square root of 6 to both the numerator and denominator, right? And in this way, square root of 6 times square root of 6 will get you 6, and 4 by square root of 6, and then can be simplified to 2 times square root of 6 over 3, right? In this way, the denominator is rationalized to 3. Okay, and let's see another example. How about this number? If we want to rationalize this number is actually cube root of 2 over cube root of 3a, right? So in order to eliminate the cube root sign here, we need to multiply a square root of 3a squared, right? Because the multiplication of these two numbers is 3a to the power of 3, and then find its third root, which is actually 3a, which means we rationalized the denominator, right? Okay, so we times the same number to the numerator, which is also the square root of 3a squared. Okay, so in this way, as we have discussed, the denominator is actually 3a, right? And the numerator would become cube root of 2 by 9a squared, which is 18a squared. Okay, and you can see here the denominator has already been rationalized. Okay, so basically this is a method of rationalize the denominator with one term. You will also encounter that there are probably some cases there are two terms in the denominator, right? So for example, there are two terms here in the denominator. How do we rationalize this? We can use this formula, right? A squared minus b squared is a plus b times a minus b. So the original expression is, so in order to remove the radical sign here, we can time a x minus square root of 3, right? And in order to keep the value equal to the original expression, we need to time the same expression to the numerator. So in this way, the denominator becomes x squared minus 3, right? And the numerator becomes 4 times x minus square root of 3. And there is no radical sign in the denominator. So denominator has been rationalized. Okay, now let's have a look at another example. For example, if we want to rationalize this expression. So note here, square root of 5 minus square root of 6, which can be rationalized by multiplying a square root of 5 plus square root of 6, right? And remember, in order to keep the value constant, the same way as the original expression, you will need also to multiply the same number to the numerator, which is, okay, so by using this formula, the denominator is 5 by 6, right? And the numerator, we can just calculate the value by expanding the expression, which is square root of 10 plus square root of 12 plus square root of 15 plus square root of 18, right? And then we can simplify the result. This is -1, so -1, and then square root of 10 plus twice of square root of 3 plus square root of 15 plus 3 times square root of 2, right? Okay. Any questions? No? All right, let's see the practices. Now it's your turn to finish the following practice. First, we have a square root of 11 in the denominator, right? So by multiply the same number here, we can rationalize the square root of 11, right? And remember to multiply the same number onto the numerator. Okay, so original number is, this is equivalent to the number here, right? And denominator is 11. and numerator becomes 7 times square root of 11. And the denominator has been rationalized. Okay. And next one. So note this ratio is equal to cube root of 5y over cube root of 2, right? So in order to move the cube root here, you need to multiply a cube root of 2 to the power of 2, right? And remember to times the same number to the numerator. Okay, so now the denominator becomes 2 raised to the power of 3, and then find its third root, which is of course 2, right? And then the numerator becomes square root of 5y times 2 to the power of 2 is 4, right? Okay, so this is denominator becomes 2, and numerator becomes square root of 20y, right? Okay, any questions? No? Okay, let's see the next one. Next one, note here we have square root of a plus square root of b, right? So we can multiply a square root of a minus square root of b, and by using the formula to remove the square root sign here. Okay, so let's do this to both the denominator and the numerator. Multiply the same number to both the denominator and the numerator, right? And denominator becomes a minus b. Numerator becomes a minus square root of ab, right? So this is a final result, which rationalized the denominator. Okay, so I have a question for you. So by multiplying these two numbers, this is actually a square and then square root, right? Can we directly write it like a square? Actually, a square and then square root equals the absolute value of a, right? This is a correct result. But note here, we already have a number a under the square root sign. That means a must be equal to or above 0. So if a is a number that is equal to or greater than 0, then this is actually equal to number a. So that's why we can write result of a here, right? So you need to understand why we can directly write as a, not the absolute value of a, okay? All right, next one. So this time we can multiply a square root of 7 plus square root of 6. So both the denominator and numerator, right? Okay. And then according to the formula, the denominator becomes 7 minus 6, right? Okay, 7 minus 6 is 1. So the final result is square root of 7 plus square root of 6, right? Okay. So next, let's consider if there are 3 terms in the denominator, how should we do? We can group them, right? We can, for example, we can group the first 2 terms together, and then how do you eliminate the square root sign? Okay, we can remove the square root sign by using the formula, right? So we can time this number to both the numerator and denominator, right? This is the first number, and then multiplied by this one. Can you see why? Because then we can use the formula. This is a plus b times a minus b, right? Which is a square minus b square. B square is square root of 5, and then square, which is actually 5, right? Okay. And for numerator, it is square root of 2 plus square root of 3 minus square root of 5. Understand? Can you follow me, Emily, Laura? How about Emily? Are you still there? Okay, so what's next? Next, we can just expand the denominator, right? Okay, so if you just expand the denominator, it is actually 2. According to the formula, 2 plus twice of AB, right? Twice of AB is 2 times square root of 6. And then plus b squared, which is 3, right? And then minus 5. So 3 plus 2 minus 5 can be canceled with each other, right? And then this is actually converted to a question with only one term that is not rationalized. So we can just time a square root of 6 to both the denominator and the numerator to rationalize the denominator, right? So this becomes, the first denominator becomes 2 by 6, right? And the numerator becomes twice of square root of 3 plus 3 times square root of 2, and then minus square root of 30, right? Okay, so this is actually 1 over 12 times twice of square root of 3 plus 3 times square root of 2 minus square root of 30, right? And we have rationalized the denominator to 12. All right, any questions? Emily? Okay, Laura. All right, let's see the last question. Okay, so last question, there is a hint which you can use the following formula, right? So basically, there is a formula saying that a cubed plus b cubed is a plus b times a square minus ab plus b squared, right? And a cubed minus b cubed is factored to a minus b times a squared plus ab plus b squared, right? So we can utilize these formulas to rationalize a difference between two cubes, right? So this is actually can be rationalized using this technique. So we have 2 minus cube root of 2, right? So if we times, first, if we time 2 square plus AB, that means 2 times cube root of 2, right? So this is our A, and this is our B. And then plus B squared, which is cube root of 2 and then squared. And note that this is actually 2 minus 2 cube minus cube root of 2 cube, right? Can you see that? Those of you. Emily? Yes, okay. So in order to keep the ratio equal to the original expression, we need also to multiply the later number here to the numerator, right? Plus. So I have a question for you. What is this number? This is actually 2 to the 1/3 and then to the power of 2, right? Which is actually 2 to the 2/3. Okay, so 4 plus twice of cube root of 2 and plus cube root of 4, right? Over this number here, which is 8 subtracted by 2. Okay, so the final result is 4 plus twice of cube root of 2 plus cube root of 4 over 6, right? Okay, do you have any questions? Okay, so basically these questions are not very difficult. So I hope you can correct your result after this class and do get yourself familiar with these techniques, okay? I think we probably would practice once or twice. Yeah, probably one more time. Because both of you have done significant errors in this assignment. So probably we'll practice one more time for the factoring techniques, okay? Before we proceed to the next chapter, which is solving quadratic functions. Okay, so I'll upload my notes onto Google Classroom, and once the new assignment is ready, I'll let your parents know, okay?